to help you for this particular time. See, introduction to machine learning. So, Daddy, introduction to machine learning. Okay, ML means machine learning. See, before we understood what exactly the machine learning and all, we need to know, the traditional programmer. Let's consider you are the Java developer. Okay, you are the Java developer. Okay, let's think about yourself only. You are the Java developer. Okay, now I have a given task like the task is like write a Java program. I have just given a question, something like that, right? Java program to solve, okay, to solve factorial of a number, factorial of a number. So this is a small thing actually. Okay, write a Java program to solve the factorial of a number. So this particular situation, what you can do as a Java developer, first you can think about the logic of the factorial. So the logic of the factorial is what? For example, if I have a number is n, okay, this is my input, okay, and so what I can do, I have to go with find that factorial for the number n. So what it will do? 1 into 2 into 3 into and so on. What could be the number we have it? Till that particular number, you have to be multiply itself, right? So that's how we are getting the factorial. So this is the logic. Okay. So this particular logic, what we are doing actually, we are building the code for the logic. So this is the logic, whatever I have mentioned over here. Okay. For this particular logic, we are going to be build the a code for using Java. Okay. Once if you build the code, what you can do, you can give some new inputs. If I give any new input, you will get the output or not? Yes or no? I need the response, guys. This is the logic. The logic, it could be a common thing. For that particular logic, we are building the code. Once if you build the code, if I give any new inputs, you will be getting output or not. For example, if I'm giving the 5, then we are getting the 120. If I'm giving the 4, then we are getting the 24, something like that. Okay. I need response, guys. If I'm not getting the response, then there is no point. Um, hello, hello, Christina and Sai Srinivas and Upender, are you following or not? If you're not following, then if you're able to follow, then please respond it at least.
Yes, Anjan.
If
Yeah,
you
we
Okay, fine. So here, this is general, the traditional programmer. Just think about yourself, you are Java developer. I just given a task, then first that particular task, you are building the logic. Once the logic you know it, then only we can start building the code. If you don't know the logic, then it's not possible to write the it's not possible to write the code, right? Okay. So this is a traditional programmer will do. So what about machine learning engineer? How the machine learning programs will work? Okay, or machine learning developer and something else. Okay, see, the machine learning engineer, he have some kind of data. Okay, he has some kind of historical data. So this is number n, and this is a fact variable. So 1, if I'm giving the 1, then it is a 1 is the result, or else 0, 2, 2, 3, 6, and 4, 24, 5, 120, something like that. He have some kind of data. Okay, so this is the data. What exactly the machine learning engineer do? He is trained with the ML algorithm. So there is some predefined machine learning algorithms are there. Okay, so the data what we have it, that particular data which is trained by this particular machine learning algorithm. Once the model has been trained, then it can be built a model. ML model has been created. Once the model has been generated, then what we can do, if I give any new inputs, If I give any new input, for example, let us take, I'm giving the 6 over here. If I'm giving the 6, then what could be the result over here? Okay, it's a 720 approximately, right? See, in this particular process, is there anywhere you build the logic? No, you're not build any logic. We are used some existing machine learning algorithm, and we are using some historical data. That's how you're trained your model. Then the model has been created. Okay. Once the model has been finalized, then you can start giving some new inputs. Then it could be generating the output for over here with help of ML algorithms or ML models. But in case of the traditional programmer, the Java developer need to be think about the logic. If and only if you know the logic, then only you can able to build the logic for that, build the code for that particular logic. But when coming to the machine learning engineer, he's not even thinking about what is the logic for that. Automatically, the machine learning algorithms generate the patterns or create the patterns, or based upon the patterns, it can be creating the model for that. Okay. So that exactly the difference between the traditional programmer and ML engineer or ML programmer. Any questions?
No.
Okay. So, but the thing is that depends upon the model predictions and model um, data type. There are two types of machine learning algorithms are there. How many types? Two types.
Four types.
What are those?
Supervised, unsupervised.
Supervised, unsupervised. Have I discussed about this particular concepts ever?
No.
Yeah, in previous class you told this one regarding classification will come under unsupervised.
Yeah. So supervised means, it's a very simple thing. So if machine learning algorithms, we are always work with the data only. Okay. So when we are working with the data, then the data we have two kind of things. One is dependent variables, and second one is the independent variables, right? Okay. So if the dependent variable is existed or which is available, that we can call it as the label data. Okay. Label data, or else dependent variables, or else target variable. If you know the target variable, if you know the label data, if you know the dependent variable, or else if we have a trainer for that, then a guide for that, then we can simply say that supervised. If in case the dependent variable, target variable, or label data, this kind of data which is not existed, then we can apply the supervised. No target data. Okay, we have only data, but there is no target data. So the example for that, um, I just given some group like I just given one features, and so based upon the features we are going to be create the clusters. Okay, you have some kind of a data set, and so with the help of this data set we are segregating different groups, clusters. Okay, automatically we can generate multiple groups. Okay, that kind of concepts we can call it as the supervised, no target variable. Okay, if you have a target variable, you have a target variable, but the target variable have two kind of data types, or it might be number type, or it might be categorical type. If in case our target variable is a numerical, then you can apply the regression models. If in case our target variable is a categorical data, for example, whether the email is a spam or not, okay, whether the person will achieve the um, you know goal or not, okay, that kind of yes or no things or categorical kind of stuff, then we can simply call it as the classification kind of models. So under the regression we have various types of regression and machine learning algorithms are there. Simple linear regression, when we have single independent variable and single dependent variable, and multiple linear regression. Multiple linear regression means we have one target variable and multiple independent variables, or else decision tree regression, or random forest regression, support vector machine regression, XGBoost regression. Okay, different kind of regression, decision tree, random forest, XGBoost, and polynomial linear regression. So something like that. So all kind of stuff we can simply say that it's a regression kind of machine learning model. And coming to the classification, there also we do have various type of algorithms are there. The first basic model is logistic regression. Logistic regression. The name why it is a regression, because which is followed the principles of the simple linear regression or multiple linear regression. Okay. That means your dependent variable are linearly depending on the our independent variables. Linear nature. And support vector mission, KNN, K nearest neighbors, and decision tree classifier, and random forest classifier, and XGBoost classifier. Different kind of classification techniques also we do have it. Okay. See, but thing is that whether the model once if you created, once if your model has been generated, okay. So we need to be model evaluation is important. So with help of this algorithms, we can able to build the model or we can develop the model. Once model has been generated or model you build it, then we need to be evaluated. Okay. So how we can able to evaluate it? If it is the regression, we do have various matrices are there. Let's talk about one after one. So R square and adjusted R square. I think you already seen this all kind of stuff, right? And AIC and BIC, Aikaika, Bayesian, and mm, based upon the significance, p-values and all. So we can able to finalize our models, or we can able to evaluate our regression models. When coming to the classification kind of stuff, there also we do have various matrices are there. The first one is the confusion matrix. Confusion matrix. And once if you know the confusion matrix, we can start building this, start getting some precisions, recall, and F1 score, okay, and ROC, AUC. So these are the different kind of matrices we can use it for evaluating the classification models. For evaluating the regression models, then we can use the R square, adjust R square, AIC, BIC, and p values and all. Any questions, guys?
No.
Okay. So definitely we'll talk about this evaluation matrices and all. Okay. Now let's talk about the logistic regression from the classification. I think from the regression you already seen that simple linear regression and multiple linear regression. From the classification, let's see logistic regression. Logistic regression. So coming to the logistic regression, and I already know which is used for what, which is used for to build the classification models. Okay. It is not for the regression. The name is a regression, but it is not for the regression. Okay. So what it will do actually, it is predicting the probabilities. It is predicting the probabilities that an input belongs to certain class or not. Okay. For example, this is my data set. These are my input. This is my dependent variable. So with help of a logistic regression, we are going to be finding the probabilities. Probabilities are between the 0 to 1 only, right? Okay, 0.2 or 0.3 or 0.7, something like that. Okay, so if it is we do have some kind of conditional number. Okay, so whether it is the less than that one, then it might be belongs to one class. It might be greater than one particular value. That is a class, some class 0 or class 1. See, typically we are following the 0.5. Okay, but this value which is set by the again domain expertise only. Okay, but typically it's a 0.5. If it is a less than the 0.5, then your probability value, it is a less than the 0.5. It could be a class 0. We have only two classes, right? Class 0 or class 1. Class 0 is no, class 1 means yes, two categories. If it is greater than or equal to 0.5, it might be class 1. Okay. So I hope you understood the threshold value. The threshold value, it's approximately 0.5. See how it will works actually. So how this will works, like we do have input features just like linear regression. This is my data set. Okay, here I have various inputs x1, x2, x3, and this is my y. And we have various data points are there here. Okay, and this is your y values. It might be 0 or it might be 1. It might be 0, it might be 1. Okay, so here 0 indicating that say no kind of category, or 1 indicating that yes kind of category, or any kind of thing actually. Okay, it might be yes or true, or it might anything, you know, it's just a two classes, class 0 and class 1. So here we have only two categories. Okay, so this particular situation, you know, our how this particular logistic regression will works, and it is having the linear combination, so we have to go for calculating that your linear equation. So for each and every input you have some kind of weight for that. Let me consider your weight is it, for example, w1 or else m1, m2, m3. This is your slopes, right? So that is the reason m1 x1 plus m2 x2 plus m3 x3 and so on. Okay, see this is how you might have it, and we do have one kind of constant over here. Okay, this is simply linear equation, right? This is simply linear equation. So once if you are able to get that, you know, linear equation with help of inputs and corresponding slopes, then with help of the sigmoid function, with help of a sigmoid function, okay, we can convert this particular linear values into between 0 to 1. So that particular sigmoid function we can represent it with sigma of z. It's a 1 by 1 plus e power of minus z. Okay, this is the formula, guys. This is the formula, is a sigmoid. With help of the sigmoid of value, you know, whatever the value we are getting, it might be any value, it might be positive number, it might be negative number, whatever it is, but it is not between the 0. Sometimes it might be between 0 also, between 0 to 1 also. It mostly it's not between 0 to 1. Okay, so this is the z value if we given to the sigmoid function, then the values, the probability values between the 0 to 1 only, because it's exponential value, it 1 by 1 plus exponential. So the max value is the 1, the smallest value is the 0. Okay, so if any case, if your sigma of z, it might be less than the 0.5, it might be class 0. If it is greater than or equal to 0.5, it belongs to class 1. Okay, clear?
Yeah,
Yes.
clear.
So with the logistic regression, which works with, based on the linear equation, that is the reason, you know, we are calling it a logistic regression. With the help of the logistic regression, we are going to be calculating the probabilities. So if the probabilities value based on the threshold value, we can able to finalize which class belongs to this particular data point. Okay, I hope you clear this particular thing. Any questions?
No questions.
Questions. So guys, this is the small theoretical concept about the classification, logistic regression. Okay, let's talk about model evolution matrices also. So can you tell me what is the use of matrices?
To know the bias and variances, like
So with
through
help of
which
model,
one is
so with help of model evaluation, so we can able to focusing on, you know, we can simply um, you know, what we can do, we can evaluate it, your model, whether the model what we are building, the model, whether it is a valid model or invalid model. Okay, We cannot trust blindly the model what we created, right? Okay. So with help of a model evaluation, so we can finalize your model. So for model evaluation, we do have various matrices are there. The very first thing is that confusion matrix. Okay. So coming to the confusion matrix, it's a 2 by 2 matrix. It's a kind of something like that. So here we do have its actual, these are the actual points. This is actual positive numbers. These are actual negative numbers. Okay. These are your predicted values. Predicted positive and predicted negative. So actually, confusion matrix, what we are doing actually. So we have actually it's a positive number and we predicted as the positive. So that is the reason we can call it as the true positive. TP means true positive. Actually, it's a positive and you are also predicted as the positive. So that is the reason it's a true positive. Actually, it's a positive, but you predicted as the negative. So it's a false negative. Okay, actually it's a positive, but you predicted as the negative. So with help of sigmoid function, we can finalize that, if it is a less than 0.5, it might be class 0 or it might be greater than, it's a class 1, right? So we are going to be predicting that whether it is a 0 or 1. But actually there could be some values are there, right? Okay. Let me consider this is my data set and this is my y values. It's a 0, 1 and 0 and 1. Okay. But this is your logistic values or sigmoid values. So based upon the sigmoid value and so if it is a less than 0.5 greater than threshold value, you're going to be saying that, you're predicted as the 1 and this is 1 and this is 0 and this is 1. Okay. So this particular situation or this is 0. Okay. Yeah. So this particular situation, actually it's a positive. Actually it's a positive, but you predicted as the negative, right? So this kind of data point we can call it a false negative. You predicted as the negative, but actually it's a positive. In the meanwhile, it's a positive, right? And actually it's a positive, and you predicted as the positive only. So which is belongs to true positive. Okay. And actually it's a negative. See, actually it's a negative, but you predicted as the positive. This is also error. And this is also error. Okay, only these two are predicted as the correct. Okay, so this terms like actually it's a negative, but you predicted as the positive. So that is the reason it's a false positive. It's a false indicating that you predicted false results. False positive. And actually negative, but you predicted as the positive, so that it's a true negative. So here the true negative and true positive or correct data points or observations, and so here the false negative and false positive or it's your errors actually. Okay, so I hope you understood right how these values will get it based upon your actual categories and predicted categories. So this matrix will be false under. So in your data points you have 5,000 data observations. Okay, there are 500 data points. Out of that one you predicted as the 200 um okay, so here actual values are 500. Out of that 300 are the positives. Okay, 200 are the negatives. These are the actual things. But when you're predicting, okay, and out of 300 positives and you predicted only 200 positives, then true positives are 200 and rest of 100 what? Actually it's a positive, right? But you predicted as the negative, right? So that it belongs to this one. Okay. And coming to that, there are 200 actual positives are there, actual negatives are there. But out of that one, you predicted 50 as the positive. 50 as the positive. That means it's a false positive. And the remaining 150 are, you're predicted as the negative. Okay. These are actually positives. You predicted positives. And remaining 200 will be predicted negatives. Okay. So actually it's a positives. Actually it's a positives, but you predicted only 200 positives. Okay. So 200. And so actually it's a positives only, actual positives only, but you predicted as the negative. So 100 are the negative. So 100 will be here. And actually it's a 200 is your negative values, but out of that one you predicted as the positive, 50 as the predicted positive. So it's a false positive. Okay. Remaining 150, actually it's a negative, you predicted as the negative. So that is the reason it's a 150. Okay. This is how the matrix will be looks like. Okay. Based upon your actual and you predicted data points, the matrix, the confusion matrix will be generated. Any questions, guys? Note this one. Okay. This is confusion matrix. If you know the confusion matrix, from the confusion matrix only, we can evaluate various matrices. The first one is accuracy. Coming to that accuracy, it's very simple, straightforward. True positives by true negative, corrected by total values. True positives by true negatives. These are the corrected elements by total data points. True positives and true negatives plus false positives plus false negatives. So this is the accuracy formula. So with help of accuracy, we can measure the overall correctness. So with help of accuracy, we can able to measure the overall correctness. Okay. Next one is the precision. So this matrices depends upon the situation. So we can use the different matrices actually. So precision, what it will do, out of all predicted positives, how many are actually positives? Out of all predicted positives, out of all predicted positives, how many are actually positives? That we can give you with help of precision only. So the formula is, it's a true positive by true positive plus false positives. You know, false positives also you predicted positives only, right? Okay. True positives only your predicted positives. And out of true positives by true positives plus false positive, that we can call it as the precision. Out of all predicted positives, how many are actually positives? Next one is recall. So we have another name for the recall. It's a sensitivity. Sensitivity. Okay. Or you can use like true positive rate. True positive rate also. Different names we can use. So here, it is also similar to the precision, but the thing is that, out of all actual positives, out of all actual positives, previously predicted positives, out of all actual positives, and how many are, actual, how many did we predicted positive? Correctly predicted. Okay. So out of all actual positive, how many you predicted correctly? So for that one, the formula is true positive by true positive plus false negative. Okay, this is the recall formula. So next one is F1 score. F1 score, it could help you, bias and your precision and recall. So that the F1 score formula is, it's a 2 into precision into recall by precision plus recall. With help of F1 score, we can trade off between the precision and recall. Okay. And last but not least, which is true negative rate, that we can call it as the specificity. It's a true negative rate. So for that one, specificity, what it will do, out of all actual negatives, how many we did correctly? Out of all actual negatives, how many we did correctly predicted?
Anjan,
Yes.
I have a question. For F1 score, the formula should be two times of numerator and denominator, right? Or is it two times of numerator?
No. 2 into precision, recall,
Okay.
F1 score.
Okay. Yeah.
It's harmonic mean, something like that. Okay.
Okay.
Okay. Specificity. You are talking about true negatives, right? No, actual negatives, right? So that, true negatives by true negatives plus false positives. And so this ROC and AUC, so which is a receiver operating characteristics, which could help you to measure the ability of model, how it was distinct between those things. And AUC, it might be value of 1. So it's a perfect classifier. If it is the AUC value, it is a 1, then we can say that's a perfect classifier. Okay, if your AUC value, if it is a 0.5, then there could be some kind of random guesses there. Okay, 0 indicating that it's a bad model. So that is the use of AUC and ROC things. So this AUC and ROC values, we can use the precision and the specificity. With the help of those things only, we can able to graph it. So if the graph, it could be between 0 to 1. So it's the area under the curve. Okay. So if this is the value, it could be close to 1. That means our model is giving a good result, good fit model actually. So that's how we know we do have various matrices. We generally use it for evaluating any kind of classification models. Okay. I hope for today's session I have explained about logistic regression and so classification introduction, machine learning introduction, and so classification model, evaluation matrices also I have explained. So tomorrow session, what we can do, we can take any one of the classification data set, and we'll try to be build logistic regression, and so we can try to evaluate it with that, no, with this particular matrices. Okay. Thank you so much, guys. If you have any questions, you can let me know.
Yeah, if AUC is 0.5, what it would be? Random successor
It's
is?
a random guess. It's a kind of random guess. That means it's not a
Okay.
good model. It's a 0.5. It's not a 5. It's a 0.5. Okay.
Okay.
Yeah. Okay. Thank you. Bye.